Hi everybody, I'm Mike and I'm your instructor for General Chemistry 1. General Chemistry 1 is a standard college freshman course that you see everywhere and you're getting the same thing here. And if you don't like the material we're covering, just wait a week because we jump around quite a bit. Today we're going to give you an introduction to matter. What is matter? I don't know, everything, anything that has mass and takes up space. We're going to talk about the characterization of matter and how it may be organized in terms of what's a mixture, what's a compound, what's an element, and then of course the three states of matter. So welcome on board. Let's go chat about matter. Well, hi everybody, hi, Mike here, and we'll start our journey now, defining what the field of chemistry is. Chemistry is the study of matter and its changes, which kind of begs the question, what is matter? Well, it's pretty easy to explain. Matter is anything that has mass, which means we can weigh it. So for example, this piece of paper I'm writing on, I could say, hey, that's matter because I could put it on a balance and weigh it. But it also takes up space or has volume. So, sounds pretty simple, right? Now you got to watch out. Your mind will play tricks on you. You say, hey, what about air? Air doesn't have mass, does it? Sure it does. It's just that it's always there, so you think, oh, I could take the air in this room. If you could somehow pump it into another container and weigh it, you'd find that the air in the room that you're in might weigh over 100 pounds. Actually, I hope it weighs over 100 pounds or you're in a closet or something like that. So that's basically the thing, is that all these phases of matter, which we're going to discuss next, are having mass and taking up space, even gases, which are sometimes tricky to think about. So let's talk about the three phases of matter. And what I'm going to do is I'm going to take a little bit more time here and try to explain to you, if you could see molecules, what would be happening. Of course, you know, you can't see molecules. If you did, if you were able to see molecules, you'd probably be working for the government in a secret capacity. But it always helps to use your imagination in chemistry, because we go flashing back and forth between what we can see and observe and what's actually going on at the molecular level. So I could take like this piece of chalk, and why is it a piece of chalk that's solid? Well, what's going on at the molecular level is the atoms or molecules are locked into place. Does that mean they're not moving? No, they're moving. They're rattling around. Those are the rattle marks. All right, so they're just kind of vibrating. But they can't slide along each other. That's what liquids do. Liquids are able to have layers of them slide along each other, and therefore that's why solids are kind of locked into place. So we say this has a definite means not easily changed, definite volume and a definite shape. So that means if I were to go and do something like put some force on this piece of chalk, I could put it back together. It would have the same, if I cared enough to get that little piece and do that. I don't really have that kind of time. But you would find that it's just going to retain its shape no matter what container you put it in. Now, what if I take this water in this glass? You're going to find out that the volume is the same, but I could take this bowl and I could pour it into the bowl, and it's going to take and adopt the shape of the bowl or whatever container I was going to put it into. And so what you got going on here, because of that ability of the layers of molecules to slide along each other, they will change their shape So this would be indefinite shape, or the shape is very passive. It'll adopt the shape of the container. But you see how there's not much space in between molecules? The volume will be the same no matter what container I pour it into. So there you go. And the reason is that those molecules can slide along each other, or shear, I guess you'd call it if you wanted to be fancy about it. All right, so now how about gas? So I'm gonna go and I'm gonna blow up a balloon here. You know, there's my gas sample. What's going on in there? Well, you notice how I made a lot of room between the molecules, and that's because what they're doing is they're flying around there randomly, and they're bumping into each other and the side of the container. And we're going to end Gen Chem 1 with gases, and we're going to find out that if this was under the conditions of this balloon, I really couldn't even draw on this diagram. What happens is generally at room conditions, gases are 999 parts out of 1,000 empty space. And so you can squeeze them. I could take this balloon, and if I had a container, well, what I did is I'll do the opposite. I let it go, and it'll adopt both the shape and volume of the container. So right now, indefinite volume. All those air molecules have filled up the room, or will eventually move around randomly until they'll fill up the next container available to it. And then of course I could have put that gas into another container and it would have adopted the shape. All right. So, and now here's what's going on. How do you get back and forth between the three phases? Well, what will do that for you is energy. So, for example, I could take an ice cube, and let's say energy is going to increase this way. So that's increasing energy, and actually we call it kinetic energy. That's the energy of motion. And so if I make big old arrows here, you can go back and forth. So if I take out of the freezer an ice cube, it'll take the energy of the room, and it will melt and become a liquid. And you could also go and put it back in the freezer, take energy out of it, and it will become a solid as it freezes. And of course that liquid right now that I poured into the bowl, very few, but some molecules will acquire enough energy to vaporize and become a gas. And then of course, they can condense, like the morning dew. And so all that requires energy to get back and forth, and all three of those phases are able to be converted back and forth. So that's a little bit about the three phases, and it's hard to kind of describe the obvious, what we're doing, but that nonetheless is what we're talking about when we talk about the three phases of matter. Next, we're going to talk about changes in matter, and I want to talk about the arrow. When we have matter going through a change in chemistry, first of all, we have formulas. So I took one that you're familiar with. Everybody knows what H2O is. Do you notice when we write a formula, sometimes we write in subscript, we write the phase. So that L means that it's a liquid. And I did that for both. The arrow means becomes or yields or changes to become. So that's kind of the language of chemistry. And we're going to talk about changes a lot in chapters 3 and 4. But these are kind of like the words, and then this is like the sentences of chemistry. So if I were to talk about water and undergo its change, like we talked about that, say you go and you jump in the pool and all the water on you evaporates, that would be called a physical change, because you notice it did not change its formula. Or if I were to freeze it into an ice cube or something like that, but that'd be less comfortable. So I like my example of it vaporizing better. So notice the formula, the molecules, the building blocks did not change from the left to the right, Before and after picture, there's still water molecules. Now, if I was to do something really crazy, like take an electrode and put a huge current and more than 3.5 volts into the water, you would convert it to H2 gas and oxygen gas, and now that is a change. Also, we have this rule where we got to have the same number of atoms on both sides. I got to put a 2 there. That 2, I'm just talking about this now, but we're going to talk about this in great detail. That 2 means 2 of what comes after it. And so these are what we call balancing the equation. But you notice what I really need from you now is just notice that if the molecules are different on the left and the right, that's a chemical change. So a good example would be like I take this match and I go ahead and do that. Now, you know, as that becomes carbon dioxide and water when you undergo combustion, that's obviously different molecules than were on the match before. And so, you know, burning something is a chemical change. Phase changes only are physical. So there you go. That's a little bit about the 3 phases of matter and the changes. And you know what, folks? We got one more thing to talk about today. I'm going to just be really kind of brief with you in this particular video. And let's talk about the organization or classification of all matter. Okay, so let's talk about how we can sort of think about the different forms matter will take on. So here's a little concept map of matter, and it's in a box, and that means everything in the universe that has mass or takes up space. We can then subcategorize all matter into 2 things from there. It's either going to be a pure substance. Let's talk about what that means. That means if you could see the molecules or atoms, there'd be only one type of building block, so to speak. Let's call it a building block for now. And you could have just one type, like so you got water, and it's pure. That would be a pure substance. Or you could take water and you could put sugar in it. Now it's what we call a mixture. So you'd have sugar molecules in with the water molecules. And I think I'm not probably losing anybody here. Let's go down this avenue here. Let's talk about the 2 kinds of pure substances. What you've got is you've got elements, and then you got compounds. What's the difference between those? I'll give you some examples, but if you have an element, oh, by the way, sounds probably pretty familiar. It's in the periodic table of the elements. So here's an element. I went into my garage and I got an element. I just had a bunch of copper wire, which comes in handy, by the way, in a lot of different ways. So there's copper. That would be called an element. So if you can find it on the periodic table of the elements, which is going to be our best friend all semester, and then it's an element. But really what you've got is only one type of building block, but they're only one type of atom. One type of atom. So for my example, copper, solid. That's an element. It can also be a molecule of itself. So that's a little tricky. Just because it makes a molecule of itself, like O2, what we're breathing right now, that's still an element. All I got's oxygen. It happens to be that some of the elements make molecules of themselves. Matter of fact, let's go ahead and talk about that. The molecules that make, the atoms that make molecules of themselves are usually gases, but not always. And the way you could remember that is have no fear of ice It's chlorine. Oops. Oops. Cold beer. Those are all diatomic elements. They make molecules themselves, and you don't have to memorize that, but you know that we'll find out why that is. So if you were to take you know, any of those elements, the nonmetals tend to make molecules themselves. Metals are much more complicated. We talk about them in general chemistry too. They sort of arrange themselves in specific ways, so they're kind of like molecules but not really. Those are independent molecules, and then there's some that don't do that. Like if you took helium, helium's happy just being by itself, and but it would be, you know, still an element. So a compound would not be that. There would be more than one. One type atom. Make sure I make delineation here. So here's your water, right? Water's a compound. We could take this, you know, here, trying to pick things that touch your life. Sugar, right? And I like Smidge and Spoon sugar. I have no idea what Smidge and Spoon is. That's just a brand name. But C12H22O11. That's a molecule of carbon, hydrogen, and oxygen. All right, folks? So you should be able to look at something, if we give you a formula of it, and say, hey, is that an element or is that a compound? Pretty easy if you only see one type of atom. And by the way, oxygen even makes another molecule called ozone, and that'd be O3. But the bottom line is it's only one type of atom, and so you'd say, oh, that's a element. And then if you see something with, you know, 2 to 18 different elements, that could be a compound, right? Mixtures. Well, here we go. Now if you take these things and mix them, how they mix determines what type of mixture they are. So you got homogeneous mixture, and that would be a uniform mixture that makes kind of only one sort of consistent phase of itself. And then I'm going to try to show you examples of both. And then I'm going to try to make it so you don't go crazy this early on in our journey. Heterogeneous mixture. All right? Now, we're here to talk for a long time. We're not going to tackle everything today, so don't go crazy, folks. All right? So if I were to go and take this water and, hey, let's put it, that's of course, that's a compound. I'll put it right there. There's water. It's a compound. I like my metaphoric use of the bowl on top of the diagram. And then I'm going to go take some Smidge and Spoon sugar and carefully add it to the water. Right now you'd say, hey, that's in two phases because all the solid went to the bottom. And so that is a heterogeneous mixture. And the way I could make it, of course, homogeneous is I don't have a spoon, I'm going to use my pen. You know, don't do this at home with your pen. Well, unless you got the top on, it's okay. And now it'll dissolve after a time and become homogeneous. Now here's the thing you can use, is a good old light source. And you could say, hey, if it is transparent, it is a homogeneous mixture. All right, and of course, if I just had a bunch of sugar in there, the light wouldn't go through. It goes through the top, you can see, right? But it doesn't go through the bottom as much. And so I should be showing you, like here, goes to the other side, there's my hand. That's what we call in science my hand, all right? Now, what I really want you to here, say, you know, where's the line in terms of like what's homogeneous and heterogeneous? You can say, hey, air is homogeneous, right? And if you're a pilot, you don't think it's homogeneous. So the further you back off, the more you find out that something homogeneous isn't always homogeneous anymore. Here, hand sanitizer. And you say, hey, that's a mixture of like this gelatinous stuff, usually glycerol and whatnot, and alcohol, and that's homogeneous, right? I don't know, look at all those bubbles, you know, and it wouldn't pass light. Well, it'll pass light through with a laser pointer here. I can go and I can say, hey, that'll make light go through to the other end. But you notice where the bubbles are, it doesn't do that. So, you know, don't kill yourself this early on, folks. But, you know, I got light coming out the other end, but it's getting interfered with where those bubbles are. So you'd be right to say it's homogeneous if you look really close, and you'd be right to say it's heterogeneous if you look really far away. So, you know, there's gray areas there, folks. We're not here to talk about the gray areas. I'm here to make you comfortable this early in the game. Speaking of which, we're done with our first lesson. They'll be usually about this long, so you can rewatch them if you need to. I know that the human attention span is usually 45 minutes on a good day. So they'll be generally about this length, or even sometimes a little longer or shorter. But next time, we're going to talk about numbers. All right? So I want you folks to go grab yourself in some fashion. I want you to get a scientific calculator. Now, let me show you mine, because this we're going to talk about next time. So this is your homework. You got to get one of these. And it's got to have the ability to do powers of 10, which is that little exponent button. You can get away without it, but it's going to be your friend if you have it. So, by the way, that costs 10 bucks. You can get that at Walmart or something for 10 bucks. I shouldn't have said Walmart. I'm not in any way endorsed by Walmart or sponsored. Folks, congratulations, you made it through lesson number 1. Next time we'll talk the SI system of metric units, which is about base 10 power, base 10 based, power of 10 based, something like that. All right, let's go have a good rest of your day, and we'll see you next time. Bye.